So next thing we talk about is searching an element in an array. Suppose if you have to search an element in the array, right, and you have not been given any information about the array, so it is a random array like this, 5 to something like this, and suppose I have to search 4 in this array, right? If it is a random array and I have to search any element in this particular array, and I don't have any information about it, the only way that I can do is I have to go to each of the element and check whether the 4 is present or not. So first I'll come to the 0th element, then I'll come to the first, then I come to the second, then I come to third. So like this, I have to iterate through each of the element to find that element, right? Iterate through each element. I have to iterate through each element to find the element, right? So what was the time complexity of this one?
Order up in.
Very nice. Cool. So now this is the basic concept. This is the basic foundation, and on which the multiple type of questions can come in. Just like, for example, when you are studying in the 12th, force is equal to mass into acceleration was a basic concept, right? And on that, all the other complex questions would be formed. So basically, in the searching questions, this is the foundation. This is the basic, which is very basic, right? But as you move on, you have to apply it in the different ways to solve more complex questions, right? So let's try to see a variation of that, right? So the first variation that I can see is that what if array is sorted? So even if the array is sorted, if you go through this, you will still get the answer, right? But since now I have got some additional information, right? The additional information is the array is sorted. So can I do something to improve the complexity? Can you guys think of anything? What do we do to search an element if the array is sorted?
Sir, I will go to the middle value.
So basically, you are trying to say you will do binary search, right?
Binary search.
Yes.
Right. So basically, if the array is sorted, then I go for a binary search, right? And binary search, how we do? So there can be two ways to do the binary search. One is iterative, and the second one can be recursive. I'll write quickly the code of iterative one, and the recursive I want you guys to try on your own. So for example, I can write the function like this: public boolean, or I want to return the index where it exists. So and find element, and then it is array. I'm just writing the pseudo code, guys, so that this makes sense. Now while left is less than right. Now tell me, the left should be less than right or left should be less than equal to right? And what difference will it make? The left should be less than right or less than equal to right, and what difference it makes? Anybody? So when left, if you write the condition left is less than right, in this case, you are ensuring that there are at least two elements. Then only you will try to figure it out. But when you say left is less than equal to right, even if there is only one element, then also you are trying to ensure that you are trying to search. So ideally, we should put left is less than equal to right. And there. Okay, so what we are doing is that to do a binary search, basically we need an array and we need to have two endpoints, the left point and the right point. And we always try to figure out what is the middle. Okay. And once we have a middle, we try to compare it with a number. And if it is equal to the number, we return that middle index. Otherwise, if it is not, there are two possibilities. Either it is more than the number or it is less than the number. If it is more than the number, it means the number that I'm looking for should be in the left part of the array, left half of the array. So I reduce the right to mid minus 1. And otherwise, my number will be lying in the right half of the array. So I make left is equal to mid plus 1. So you can see that, whenever I'm running this loop, now if I have to find the time complexity of this loop, I have to figure out how many times this loop is running, right? How many times this loop is running. Now, since I see that, every time the size of this whole array is reduced by half, right? Either I'm checking the first half of the array or the second half of the array. Every time it is getting reduced by half. So that is why the time complexity is log of n. So that is why when you do a search in a sorted array using the binary search, you get the time complexity as log of n. So this I have done. As assignment, you should try the recursive approach of the binary search as an assignment. Any doubt on this?
I'm good.
Cool.